Hi everyone, let's try implicit differentiation on sine y over x plus x equals x cubed y. And our goal is to find dy dx, which means we'll be looking at y as the function and x as the variable. So first we need to take the derivative with respect to x of both sides. So we'll have a sine x over y plus x, and the derivative with respect to x of x cubed y. Okay, so starting on the left, I have a sum, so I get to look at the two pieces separately. Sine of x over y will require a chain rule. It's not just plain sine x, that I could do without a chain rule, but sine x over y I'll need it for. The outer function is sine, so we'll start with the derivative of sine, which is cosine, and we won't touch the inner function in this step. Now that we're done with the derivative of sine, we will focus on the inner function x over y, and that is a quotient, so we will need to chain out a quotient rule. On the bottom, we'll get y squared, and then we'll need y times the derivative of x with respect to x, which is 1, minus x times the derivative of y with respect to x, which we don't know, so we just write it in there, dy dx. Okay, so we're done with everything in front of the plus sign. After the plus sign, we just have an x. The derivative of x with respect to x is 1, so we are ready for the right-hand side. The right-hand side is a product, x cubed times y, so we will want the y, the second, times the derivative of x cubed, which is 3x squared, and if you need to think it through one step further, it would be dx dx, which is 1. Then we need the x cubed times the derivative of y with respect to x, which again we don't know, so we'll just write it in. This makes a pretty good algebra tangle. In particular, what I'm noticing is that I have a dy dx stuck in this ugly fraction. So I think I'd like to clear the fraction, but I'm going to have to do it carefully because that cosine x over y is attached to the fraction as well. So I think what I'm going to choose to do first this time is to multiply those fractions together so that I don't make any mistakes with that y squared. So I will end up distributing that cosine x over y through the top, and I'll get a y multiplied by the cosine x over y for my first product, minus an x cosine x over y times a dy dx from my second product. And then on the bottom, I just have the y squared, and that's plus 1 equals 3x squared y plus x cubed dy dx. Okay. Next, I'm going to go ahead finally and clear that fraction so that dy dx is not stuck in it. So I need to multiply both sides by y squared, and be careful, I think it would be easy to forget to multiply the 1 by y squared. Okay, so on the left, when I multiply that big ugly fraction, all that happens is the y squared cancels from the denominator, so I have the numerator left over. Y times cosine xy minus x times cosine xy, x over y, dy dx. And then again, don't forget to multiply the 1 by y squared as well. On the right-hand side, I will distribute, and I will get a 3x squared y cubed plus an x cubed y squared dy dx. Okay, so dy dx is no longer stuck in a fraction. I do have dy dx's floating around on opposite sides, so I think I'm going to move dy dx's over to the right-hand side, and while I'm at it, I notice that on the right-hand side, I have a 3x squared y cubed that I would like to move to the left-hand side. So I'm not doing anything with y cosine x over y. I'm not doing anything with the y squared. I have subtracted 3x squared y cubed from both sides to move that term to the left. On the right-hand side, I'm not moving the x cubed y squared dy dx, but I do want to add the x cosine x over y dy dx to move that to the right-hand side. Okay, so I'm almost done. I need to factor out dy dx, and I'll be left with x cubed y squared plus x cosine x over y. And on the right, I haven't done anything, so I'm just copying that back down. You'll get tired of writing these big long things. Okay, so last step, and I'm running out of room here, so I'm just going to cross this off and say this is attached by multiplication. So to solve for dy dx, I will divide both sides by x cubed y squared plus x cosine x over y. And that is my final answer. Since I dealt with the fractions in this equation early, I don't have any fractions to clear at the end. So just like that, looks great. All right, thanks for watching.